if we are trying to derive this, what you did is you derive that, that's 2x. When you derive this, you get 6y, y prime, because every time you derive y, you have to put y prime. And the 2 times the 3 is 6, and the negative. Here's a product rule. So I left the 2 out. You could have brought the 2 along as 2x, or you could take it out. And then you product rule this. So derive that, leave that, derive that. Don't forget y prime. This is 4. After you do all this, your goal is to get y prime all by itself. So you first distribute the negative 2. Then you move all the y prime to the left and everything else to the right. You pull the GCF of y prime out. Then you divide what's left over. And once you divide what's left over, you want to, in this situation, pull out a GCF of both top and bottom because it actually can cancel. When you do that, this is your answer. There are different versions, but you should have something of this version. That's implicit derivatives. Now this is an implicit, but a second derivative. So, for this one, I derive it, so this ends up being BAM, and this one is right here. Derivative of 5 is 0. I get y prime by itself, so I basically move this over, divide by the negative 4y. Now am deriving this. When I derive this, I left the 3 out front. Right here, I have a quotient rule. But this little y prime has to be replaced with that answer right there. This y prime has to be replaced, so I stuck it right in there. That's where this comes from. Because when you go x to the third times this whole thing, you get 3x to the 6 over y. To get from here to here, I had to get a common denominator right here. So to get a common denominator right here, I multiply top and bottom by y. Thus, that's where the y becomes a y squared. And the y here on the bottom of this thing combines with the y squared, leaving you y to the third. Then you can pull the GCF of x squared and 3 out of this, making a 9 x squared. And that looks like the best possible, everything pulled out answer.